Hello everyone, myself Yadagiri, Assistant Professor, Department of Electrical and Electronic Engineering, MLR Institute of Technology, Hyderabad. So in this session we are going to discuss about the Kirchhoff laws and also the overview of the Kirchhoff laws and also where we are using the Kirchhoff laws in the electrical circuits. So that many things we have discussed in this session. So the Kirchhoff laws are introduced by German physicist. So that is Gustav Kirchhoff. So there are the Kirchhoff laws are two categories. One is a Kirchhoff current law, other one is a Kirchhoff voltage law. So both Kirchhoff laws are used to analyze the electrical circuit response. So means we need to analyze the overall circuit response by using Kirchhoff laws and also the individual element response. So that is the purpose of the Kirchhoff laws. So there are the two kinds of Kirchhoff laws are there. That is a Kirchhoff voltage law. Other one is a Kirchhoff current law. So now let us discuss about the Kirchhoff voltage law. So the Kirchhoff voltage law is applicable for closed loops only. Closed loop circuits only. So which states that. So in a closed loop, algebraic sum of the voltage drop across the each and every element plus source voltage should be equal to 0. So that is the statement of Kirchhoff voltage law. Also other words, so we can say the Kirchhoff voltage law states that in any closed loop, algebraic sum of the voltage across the each and every element must be equal to 0. So other sentence also we can define the Kirchhoff law, that is in any closed loop, algebraic sum of the voltage drops are equal to the algebraic sum of the voltage rises. So these are the statements of the Kirchhoff voltage law. So we need to go with the standard sentence. The notation for the Kirchhoff voltage law. That is a standard statement for Kirchhoff voltage law. That is, so it states that in every closed loop, the algebraic sum of the voltage drop across the each and every element plus source voltage should be equal to 0. So according to this one, let us take this closed circuit. So we need to give the voltage is a V1. So this is the element number 1 is a R1 we can take. So this is a R2 element. Now this is a R3 element. So need to assign the polarities of the each element. So the voltage source, the current in the voltage source should start from the negative to positive. That means the current enter with the negative and leave from the positive terminal. Here the passive element, that is a resistor, the current enter with the plus sign and leave by the minus sign. This is called voltage drop. And here also the current enter with the plus sign and leave by the minus sign is also called voltage drop, and other one also voltage drop. So now let us apply KVL. So before going to the apply the KVL to write the loop equation, so first of all we need to assign the current direction in the loop. So that we should assume the direction of current in the loop should be clockwise direction. So it's also assume sometimes anti-clockwise direction also, that is also same only. We got the same equation only. So according to that we need to apply the Kirchhoff voltage law in the loop. We will get that is minus V1, so plus V2 plus V3 plus V4 equal to 0, plus V4 equal to 0. So this statement, this equation we have to write with the help of the statement. In every closed loop, so algebraic sum of the voltage drop across the each and every element plus source voltage should be equal to 0. So that we got V1 equal to, so V2 plus V3 plus V4 plus V4. So this is the simplified expression. So while writing the voltage equations of the each and every element, either we need to represent with the positive or negative sign. That means current entering sign of the element and also the represent with the current leaving sign of the element. So whatever we need to follow we will get the same thing only, same response only. So need to elaborate the voltage of each element. So that is here I into R1 plus here I into R2 then plus I into R3. So this is the voltage across the each element according to the Ohm's law. So the current flowing through the loop should be assumed as a current capital I. So this is the V1 as a source voltage or total voltage of the circuit. So here, which means we need to write, I need to take it as a common, so that we will get R1 plus R2 plus R3, R1 plus R2 plus R3. So from this one we will get the overall response of the circuit, that is V by R1 plus R2 plus R3 we got. So this is the overall response gained from the circuit due to the applied voltage. So based on this current, we need to find out the individual current through the each and every element. So this is the Kirchhoff voltage law. Now coming to the Kirchhoff current law. So it's also applicable in the electrical circuits only. In every electrical circuit, the Kirchhoff current law states that algebraic sum of the current enter into the node equal to the current leaving from the node. So that is the statement of Kirchhoff current law. So the Kirchhoff current law is applicable in the electrical circuits, which states that in every circuit at a node point, algebraic sum of all the currents are meeting at a common point or node point that should be equal to 0. So these are two statements from the Kirchhoff current law. So we need to follow the both based on the requirement. So that is, it states that so in every electrical circuit, algebraic sum of all the currents are meeting at a common point. That point is also called as a node point, or junction point is must be equal to 0. Or other words, also we can define the Kirchhoff current law. So that is, in every electrical circuit, node point as a reference. So this node point as a reference, incoming currents are equal to the outgoing currents. So from this one, we need to write the I total as a total current of circuit. And then the remaining all currents are so leaving from the node point. So that we need to identify or need to represent with this all currents are with the minus sign, because all are leaving from the node. So that the corresponding equation should be like this. So that is, algebraic sum of all the currents are meeting at this particular point should be equal to 0. So simplify this one, we will get I total equal to I1 plus I2 plus I3 we got. Means incoming currents are equal to the outgoing currents in the every electrical circuits. So this is Kirchhoff current law. So the Kirchhoff current law is working under the base of the law of conservation of charge, and the Kirchhoff voltage law is invented based on the principle of law of conservation of energy. So based on that, so the Kirchhoff voltage law is called as a loss of energy, and based on that, the Kirchhoff current is also called as the law of conservation of charge. So both Kirchhoff laws are used to analyze the response of the any element and also the whole circuit response. So for that, we need to discuss about one numerical. So based on the Kirchhoff voltage law, so this is the given circuit. So using the circuit, so we need to apply the Kirchhoff laws to determine the current through each branch. Current through each element. So this is the branch 1 and branch 2 and branch 3, this one. So based on this one, need to find out the current through each element or each branch. So before going to apply the Kirchhoff voltage law, first we would like to identify the number of closed loops. So in this network, we need to find only the two closed loops. That is the loop number 1 and the loop number 2. So the loop number 1 current I am going to given as a I1, and the loop number 2 current as that is I2. So this is I1 and this is I2. So first we need to apply the Kirchhoff voltage law in the loop number 1. Then apply KVL. So to find out the required values, need to apply the KVL in the loop number 1. So that is, we need to write this is the minus to plus. So this is the plus to minus. So for this element also, this is a plus to minus. So this is a plus to minus. So for this element, this is a plus to minus. It is a plus to minus. And coming to this one, minus to plus, and coming to this one, plus to minus. Then apply the loop, KVL equation in the loop number 1. That is, we will get minus 6 volts plus 2 times of I1. So because the current flows to the loop number 1 is I1, that's why the voltage across this 2 ohm resistor is 2 times of I1. So plus the next element. So that is a element, again 2 ohm resistor is there. So the voltage across this particular element is 2 times of, it is I1 minus I2. So plus 4 equal to 0. Means we have started here and also end by the same point. Means we have finished the a complete loop. So that's why we got this expression. So it's a minus 6. The voltage across this element is the 2 times of I1, and the voltage across this element is 2 times of I1 minus I2. Why? Because so the loop 1 current enter into this branch is top to bottom, and the loop 2 current is enter to the same branch with the bottom to top. That's why the overall current through the 2 ohm resistor should be difference of those two currents. So that we got the current, the voltage drop across the 2 ohm resistor is 2 times of I1 minus I2. Then simplify this expression, we will get. Simplify this expression, we will get that is a 6I1, then minus 2I2, minus 2I2, then minus 2 equal to 0. So that is a 6I1 minus 2I2 equal to 4. So this is the equation number 1. Then similarly we can apply the Kirchhoff voltage law in the loop number 1. I mean loop number 2. So because we have already gone through the loop number 1, so need to apply the KVL in loop number 2. So according to that, so need to start from the across the 4 ohm resistance onwards. So the corresponding 4 ohm resistance voltage is a plus 4 times of. Means I would like to always represent the voltage of each element with the current entering sign, so that I'm going to take plus 4 times of I2. Then so this voltage is a plus 2, then minus 4, then here, then plus 2 times of again I2 minus I1. So previously we have considered the loop number 1, so that the corresponding voltage across the 2 ohm resistor is a 2 of I1 minus I2. Here we have considered the voltage across the 2 ohm resistor, means in the loop number 2 we need to approaching, that's why I2 minus I1 we got. So this is 2 times of I2 minus I1. So final expression we got from this one, that is a 2 times of I1 plus 6I2, and then minus 2 equal to 0. Then after simplify this one, we got that is 2 of I1 plus 6I2 equal to 2. So this is equation number 2. By simplifying or by solving the equation number 1 and 2, so we got the I1 and I2 values, means we need to find out the current through each resistor or each branch. For that need to do some simplification here, so that the equation number 1 multiply with the equation number 1 multiply with the 1 we will get, so that is 6I1 minus 2I2 equal to 4. Then the equation number 2 multiply with the 2, that is 3, we will get minus 6I1 plus 18I2 plus 6 we got. So these two gets cancelled, and final expression after simplification, that is plus 16I2 equal to 10 we got. Then I2 equal to 10 upon 16. So this is the current flows through the second loop. Then similarly we need to find out the current flows through the other element. So this I2 value substitute in any of the equation. So I'm going to substitute the same value into the equation number 1. So I2 value substitute in substituting equation number 1. So that 6I1 equal to 4 plus 2 times of 10 upon 16 we got. So this is 8. Then 6I1 equal to 4 plus 6I1 equal to 4 plus then 10 by 8. Then 32 plus 10 upon 8 we got finally. Therefore I1 equal to then 42 divided by the 8 into 6, which means 42 upon 48, and therefore the current flows through so this resistor is a 42 upon 48 ampere. So this is the way of determining the response of each and every element, and also the whole circuit. So based on the requirement, we can apply either Kirchhoff voltage law and Kirchhoff current law. So that I'm going to use always the Kirchhoff voltage law to get the response of the required elements in the electrical circuits. So this is one of the example. By using the Kirchhoff laws, we will get the current through each resistor or each branch. Then the summary of the Kirchhoff laws, summary of the session. So here we have till now discussed about Kirchhoff laws. So the Kirchhoff laws are invented by the German physicist, that is Gustav Kirchhoff. So the Kirchhoff laws are two types of Kirchhoff laws are there. One is the Kirchhoff voltage law and the Kirchhoff current law. So the Kirchhoff voltage law, so working under the basis of that is the principle of law of conservation of energy. So this one is invented under the basis of principle of law of conservation of charge. So which states that which states that in every closed loop algebraic sum of the voltage drop across the each and every element plus source voltage should be equal to 0. This is KVL. And Kirchhoff current law also applicable for the each and every closed circuit. I mean, circuit means only the closed circuit. That is a closed path only or closed loop only. Means it's also applicable for circuits, electrical circuits, which states that in any kind of electrical circuit, algebraic sum of all the currents are meeting at a common point must be equal to 0. That is a Kirchhoff current law. So by using the both laws, we can get the response of the any kind of electrical circuit and also the response analyzed by the each and every individual elements based on the Kirchhoff voltage law. So both laws are applied to the any kind of electrical circuits based on the requirement. We can get the response. So either we need to use to get the response of circuit by the KVL and also the KCL. So these things we have discussed in this session. So in the next session, we would like to start the series and parallel connection of the resistors. So thank you one and all.